Hey Algebra 1, today we're going to work on combining like terms, and we're going to go through many examples. So we're going to start with this really long problem under the parts of expression list where it says 7x plus 3 subtract 5x plus 8 plus 4x minus 1. And it's broken up into variable terms, coefficients, and constants. So variable terms, oops, I just realized I forgot an x, are the numbers with all of the variable x next to it. So the 7x, negative 5x, and 4x. The constants are just the numbers that don't have a variable. So that would be the 3, the 8, and the negative 1. And then under the variable terms, coefficients are the number in front of the variable, and that would be the 7, the negative 5, and the 4. So we're going to use those terms throughout today and further into Algebra 1. So we're going to start first by combining like terms and using some of these variables and coefficients and constants. So first it says you can simplify an algebraic expression by combining like terms. So that's our main focus today. This means to combine common variables. We can combine common variables and constant terms. All right, so here's an example. I'm going to use different colors to try to help you all see it. Okay, so to start with just the coefficients with the variables. So this would be a like term, 7x minus 5x plus 4x. So you're always taking the sign in front of what you're adding or subtracting. So this reads 7 subtract 5 plus 4, which we know is 6. And the x stays there. You don't add those up into exponents. And then all the constants, we're going to combine those. So the plus 3, plus 8, minus 1. If you go across left to right, that's going to give you a positive 10. Okay. So I'm going to go through some examples here. Let's see. So we'll start easy and then go to the back page where it gets a little bit more difficult. All right, so we're going to simplify each expression. So let's start with number 1. There are no constants, there are only coefficients with the variables, so we can just go left to right. We know that 3 plus 6 is 9, and the variable goes along with it. And that's all for number 1. For something like number 4, we only have the one variable. There's nothing to combine it with because there is no other w anywhere. So you're going to write that first because the variable, if we can help it, should go first. And then the other two are the constants. So the 9 plus the 5, which is a positive 14. Okay. Looking at number 5, we have constants and variables. Right now we have 4 terms. So I'm going to start with the p's and combine them. I have 7p, and that sign stays with it, minus 9p, which is a negative 2p. And then our constants of the negative 1, oops, I didn't mean to cover it, plus the 5, which we know is positive 4. Okay. Number 6, same thing. You have the variables of h. They're both positive, so you're going to add them to get 12. And then the constants are in the middle, the negative 6 minus 8, which is a negative 14. All right. The two on the bottom are a little bit more difficult because they have x's and y's or a's and b's like a number 8. So I'm going to go ahead and give a try to number 7. So I'm going to start with the first letter that comes in the alphabet, which is x. So I'm going to add up my x's. You have the 5x, you have a negative x, and a 3x. Go left to right. That's going to give you a 7x. And then you need to combine your y's, so your positive 7y plus your 2y, which is a positive 9y. Okay. Go ahead and try number 8 right now. So go ahead and work through number 8. I'm just going to underline, and then tomorrow I want to see your guys' answers. So I'll just underline it for you. And then show me your answer tomorrow. Okay, so flipping on the back. we have more examples. So let's go ahead and jump to number 9 because now we have exponents. So terms with the same exponents or combinations of variables and exponents are considered like terms. So when you combine your like terms and they have exponents, do not change their exponents. And I'll show you what I mean in a second. For example, number 9. Not only now do we have the variable x next to our coefficients, but we also have the exponent of 2. You add your coefficients to get 12. And like I underlined, do not change their exponents. So you leave it as x squared. Okay. Same thing for number 10. We have the coefficients. Negative 15 plus 4 gives you negative 11. Do not change the exponents. They stay n to the 5th. Okay, number 12. We have a little bit more going on in number 12, so zoom in. Okay, so for 12, we have k squareds. Those are like terms because they're both squared. 8 minus 2 we know is 6. Leave the exponent alone. From there, we're going to combine the k's. So we have negative k minus 5k. They're both negative, so you add them to get negative 6k. And then there's only the one constant of the positive 7, so it's going to be plus 7 at the end. Okay. I'm going to drop down to 14, because now we have x squares, xy, and a y squared. And the yellow wasn't a good color. Okay. So I'm going to start with x squared, because again, that comes first in the alphabet. Is there anything to combine x squared with? The answer is no, so you just bring that down in the front. The next thing is going to be the xy's. So we're going to combine the plus 2xy and the minus 7xy to give you a negative 5xy. And then lastly, we have to deal with this 4y squared. There's nothing to combine that with because there's no other variable of y squared, so that will go on the back. Okay. Examples like that are setting us up for other things in the future. Okay, so I'm going to do number 16. Okay, let's start with our x squareds. We have 4x squared minus 3x squared, which we know is 1. 4 minus 3 is 1. If you wanted to write the 1, you can, but you don't have to. But I'll write it for right now. So you have 1x squared. Next will be all of your variables of x. So your 2x and your 8x, which we know if you add them, you get 10x. And then moving right along, we have our constants of negative 7 minus negative 6, which is negative 13. Okay, you can also write this, instead of writing this 1x here, you don't really need that. So the best answer would be x squared plus 10x minus 13. But that's just a preference. I would like you guys to try 15 for tomorrow. Combine your like terms. So sift through the a squareds. Sift through the ABs together, and then take care of this. So I want you guys to do 15 on your own. The perimeter on the bottom. Perimeter means the sides all added up around each figure. So we're going to find the perimeter of most of these, if not all, given the time. So the perimeter of a triangle would be us adding up every single side. So let me pick a darker color. So P will equal, we have this side length, so 2x plus 1, plus this side length of x, plus the last side length, which is 3x. Okay. We are going to combine our like terms, so 2x plus x plus 3x would give you 6x. And then the constant doesn't have anything next to it, so that's just going to be plus 1. So perimeter equals 6x plus 1. Number 19, same thing. Now not every side is labeled, but the perfect thing about a rectangle is if one side is 3y minus 5, that means the side opposite is the same. Same thing with the y plus 2. If it's that on the right side, it's also that on the left side. Okay, so we're going to combine our like terms. Let's see here. We have perimeter equals. We have our y plus 2 plus the 3y minus 5 plus the y plus 2 again plus the 3y minus 5. Combine all of the y's together. So with this one, here, here, and here, that's going to give you 8y. And then what color did I? Black. Then you're going to combine your constants, so 2, negative 5, 2, and negative 5, and that's going to give you a negative 6. So perimeter equals 8y minus 6. Number 20 is a long one, so I'm going to show my work as we go. Okay, so we have k's, k-squareds, and constants all within the problem of this trapezoid. So I'm going to start with the k-squareds, because that's the highest degree. So we have k squared, a k squared there, some there, and 1 there. And I'm just going to add those up from the get-go. So 1 plus 1 plus 1 plus 2 gives you 5k. And remember, you do not touch the exponent, you leave it squared. Next, you're going to count up all the k's. 1 minus 9 plus 1. That's going to give you a negative 7k. Lastly, you are going to add up the constants of positive 23 minus 17 to give you a plus 6. Okay. What I want you guys to do is I want you to try 18 and combine all of your like terms to find the perimeter. So I'll give you a head start. You're going to combine all of your a's, get your constants together, and then the other one is anything that aligns with the 4AB. So I want you to go ahead and try your best with those 3 examples. So I want you to try 18, 15, and the other one was number 8. So go ahead and try 8, 15, and 18 for your homework on top of filling out the notes. Have a great night, and I will see you later.